things are. Let me organize real quick. Okay, let me share my screen. No, stop sharing. Share. How do I share entire screen? Yeah, there we go. So if I switch between code and a slide, it looks good. Okay, perfect. All right. Well, thanks for making the time. 19 minutes is a lot of time, so I'm really like happy and glad that I have a couple of faces to look at while I rant about DPLYR and TIDYR and everything you can do in R. Well, kind of a little bit of this and that, but it's kind of like a list of things that I find very cool to have learned in my current work. And when I joined DRC, I knew some R, but my code was not good. And Janusz can probably tell you guys about where I was and where I've come. But I think this is not too difficult if you see me do it once, and hopefully you'll use it. But the goal for today is like we'll start with like the basics of R programming, right? Which some of you have already like used R in one way or the other, but a few basics that are necessary to kind of revise as we go into like more complicated transformation, like the basic thing, what is a function, right? Everything we do in R will be a function, and it'll go over that. Then one of the favorite thing of DAIRC in general is pipes. The way we write code is it has the same syntax where we'll talk about pipes and the tidy syntax of how we like chain different codes. It's kind of like a chain of that thought, like you're exploring, so you're like, I want to do this now, but wait a second, I needed to do this like 2 steps before, and you can quickly do it instead of rewriting the whole code. And then we'll dig into like, okay, how do you use DPLYR to explore a data set? And then we'll take a little break, come back, and we'll do a few more things of like, okay, let's now reshape data. Like, you have data in your rows. Suppose for like we are all used to longitudinal data where the same participant have multiple events or multiple visits. And usually you have, oh, participant A at visit 1 has some value, and participant A at visit 2 has some other value. So it's all rows, and we'll try to reshape them into like columns. So you kind of do that, and then we'll join data. And I know this is nothing about visualization, but I cannot think about data without having to visualize data. So my goal is that, so there's a beautiful package, PLOT.MATRIX. All it does is it actually lets you visualize. If you're looking at numbers, a table, it just visualizes that table into something that you can just, stare at, and it's not crazy because it's not numbers, it's actually plot. So that's the goal. And I want this to be as interactive as possible. Interrupt me as many times as possible. And if someone, if I ask a question, oh, do this, and you get it done, I would rather you have an error and you are okay with sharing with everyone the error you're getting so you can figure out what's happening with the error and how you can resolve it. So yeah, I mean, it's low key. There's nothing crazy here. So I'm gonna. So can someone just show of hands? I know there's like some of you are off camera. That's completely fine. But who has never used R? And that's completely okay. Okay, Tilly, lovely. Because then I can start here. It's like I have a use case scenario of like this. What I'm sharing here is an RStudio, right? And RStudio is a graphical user interface which has like 4 panes, as they call it. The way mine is set up. Okay, so when I actually let me move this. All right, so hopefully, can you see all the different keystrokes that will appear somewhere here if I can you see okay. So this is basically, hopefully you'll see, like I will use a lot of shortcuts here and there, but those will become handy as we code, because it's just a pain to like get a few things together and type it all the time. So if you're in Windows, so right now I'm doing Command M, for example. So this is the command sign and this is the M. So on Windows, it'll be control. So that's the only difference. Panes. So we have 4 different panes. Oh, Olivia's here. Hey, if anyone has questions, throw it in the chat. We have the most experienced person here who can give you answers on the chat if I am not like cognizant of what's happening on the chat. Actually, there is something in the chat.
The chat is turned off for this meeting. I'm not sure if you can turn it back on.
Laura, would you be able to help with that?
Let me look. It should be there.
Okay, it just showed up for me now.
Okay,
Okay,
yeah,
I was gonna say
yeah,
it might just
okay.
be external folks have a little bit of a different view. It sounds like Kim and Tilly and Stephanie can see it, so I think we're good.
Okay. All right, sweet. But also, I mean, I might not look at it because I get distracted very easily. So if you have a question, feel free to unmute yourself and just ask me the question. So there are 4 panes, 4 different tabs in R. So usually you have this console, like I have rearranged it. So how do you even get to the settings where you can rearrange? So if I want to bring it back, so I said it's command comma, or if you don't remember, you go to File, and actually now you go to RStudio. Where's Preferences, Tools, Global Options? God, get used to the shortcuts and forget where it is. So if you go to Tools and Global Options, this opens up, and this has a few things you can change. For example, the general is just like what is your default working directory. If you're opening RStudio and it's not our project, it's likely I'll mention what our project is. You can change these things, but honestly, nothing that I would say I recommend you do anything here. What we want to do, which I love to do, is appearance. I want to make sure my RStudio looks something that I want to go back to every time, and which right now I'm using this theme. So there's a bunch of different themes you can select for the editor. You can select this. If you apply, this will become that. I like idle fingers, so you play with it, figure out what you want. So that's one. You can increase or decrease the font size here by default. So you can make it bigger, and if I apply, this will all slightly get bigger. I'll bring it back to 16 or something and apply. So this is just appearance, right? Your appearance changes and whatnot. Pane layout. So there's like 4 things, and you can see here there are 4 different things, different views given to you, and you can select the top left, what it should be, top right, what it should be. Usually what happens is you get the source is here, the console is, I forget what the official is, but you have like 4 things. Source is where you'll have your scripts. So if I change it back to console, so on the right side, what you see is basically a text editor. It's a fancy text editor, and let's say I will remove all of this. How do I move that? Move. So I can remove this, don't save. I also remove this. So by default, if you open your RStudio, you might not even see your source pane because it's a text editor and you need to open a new R script or a different file to see that source pane. So if you don't see it, you'll go to File, and you'll go to New File, and there are different things you can do in RStudio. You can just create an R script that basically has only R code. You can do Quarto document presentation. These are things that can generate a HTML file and a bunch of other things. For our use case, we're just going to stick with R script. And you can see there's a shortcut usually next to it, which is Command-Shift-N. Like most documents, Word documents, it's like a Command-N creates a new document, right? In this case, it's Command-Shift-N. But I click this, there you go. Usually you get a untitled. Also, is the font size good for everyone, or should I make it bigger? Good, okay. Let me know. So usually it's untitled. So by default, it opens our script, and the good thing to do is always save it, because different machines work differently. Sometimes your machine will crash and you realize you have been working for 2 hours and you forgot to save it. So what we'll do is you'll say Command S, and it opens like a little window, so you can basically save it somewhere. So I'm currently in this folder called DPLYR TIDYR, and I have a bunch of different things in here, but not necessary, but I usually like to keep my scripts in something called scripts. And I can say live demo and save it. So that way, now if my R crashes, whatever state it crashed in, hopefully I get something back. I mean, the moment you start typing, you'll see it becomes, like if I go back, it's like something like this. And if I start typing, it has an asterisk. That means you haven't saved it. So it's a good habit to like, every now and then just save it. So Command S again will save it. Okay, what I will do. So this is your R script, right? This is the text editor. So in text editor, you can write whatever you want. You can write blah, blah, blah. But the magic happens is in the console. The console is basically like your terminal, or your for your Windows, it's, I don't know what they call it, but it's your command line. So what happens, the text editor, like it's like a text editor, you can say whatever you want, but you can run specific chunks of specific lines. And when you run it, there's a button here called run. If I click this, it's trying to run this first line. And what it does, you'll see on the left side, it just passes it on to the console and it says, hey, run this thing. And of course, when they run it, it says, what is blah, blah, blah. They don't understand what blah, blah, blah is because it's not our code. However, if I put it in quotation, right? If I put like quotations around it and I run it, and how do I run it? The shortcut is Command Enter or Control Enter. So if you are any place on this line, you can click Run, or you can just do Command Enter or Control Enter, and it passes it on to the console here, and it says, now it runs and it outputs basically this thing. Now, can someone tell me what is this thing? Like this thing we saved is it's a vector. You have heard about vectors in R? So these are different data types, and we'll go into slightly different. So whenever we put a quotation mark around something, that is treated as a character. Suppose I want to get the numbers 1 through 10, and I run this, you will get it's basically this, I don't know what you call it. It's colon. So 1:10 is telling me, give me all the numbers from 1 through 10. And it's represented here. Again, it gives you it passes it on to the console and it prints it out. Now, for most cases, if you're doing general math, sometimes you can use this as a calculator, right? You want to do some math, you can come here and you can basically type it out. Okay, 100 plus 200 plus 340, whatever. And then you can run this and it will give you the output. So you can do your basic calculator stuff here. But most cases, if we're programming and you're going to use and do data transformations and everything, we want to save things so that we can like slowly but gradually get the things we want. So the easiest way to save something is right now, it's just being passed on and presented here. I'm just going to remove. So these are the two things we talked about. So now we're going to move into environment slightly. So you'll see environment might be located on your left side or right side, depending on how your thing is set up. And if you don't see environment, sometimes it's clicked, you have clicked history or connections or tutorial. These are other tabs that we don't necessarily use. Environment is just showing you. So everything happens in memory, right? The moment you open RStudio, it's a contained part of your computer that is holding on to different things. Because I was working in this RStudio session for a while, it has saved a bunch of stuff, but sometimes you want to start clean. So how do you clean and remove everything and start fresh? So the command for this is rm, which is remove, and then you do parentheses and you say list equals ls. And all it's doing is basically saying remove, and it's saying remove what? So it said list equal ls. ls is basically saying list all the files in my current directory. So the moment I do this, it will remove everything in the environment. Now the environment is empty. Another good thing after you remove everything from the environment is to restart R. If you restart R, there are certain R processes that get restarted. So you actually start clean and fresh. And how you do it, you go to session up here, and there is this restart R command. Now there's a shortcut that might be available and might look different. For me, I have set my shortcut to be Command Shift 0, but it could look different for you. So if you like shortcuts, take a look. If not, you can click restart and you'll see in the console, it says restarting our session. It's already restarted because every time you see this arrow, it basically means it's ready for you to do something. Now, when I restarted R, you see there's a function that got loaded by default, right? Don't worry about it, what this is, but what you can do, I said you can run this line to remove everything from your environment. The other option is you can click this little sweep, I don't know, this broom icon here. And if you click this, it says, are you sure you want to remove all objects? You can say yes, and it does the same thing. So if you don't want to remember this code chunk, you can come to environment, remove this. Okay. So global environment is so when you copy something on your computer, right? You copied something from Word document and you're going to go and paste it in Outlook or Gmail or whatever. So there is a similar concept of global environment for your computer where it stores certain things. It knows that it can go between apps and stuff. In the same way, in our studio session, there are global variables and global environment. So this blah, 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 suppose I want to save it in an object called A. So I will say A equals, and this equal sign basically says assign whatever is on the right side to the left thing. And if I run this command, you can again run it using this, or you can do Command Enter. Now you will see it just shows up in your global environment and in the terminal, you see it doesn't really print out blah, blah, blah. All it prints out is A. Okay. Same thing with the second vector. Instead of equal, you can also type this. And this is something we use a lot, is an assignment operator. It's basically greater than sign with a dash. And you can get it in most computers. You should be able to get it with a shortcut, which is option dash or option minus. It's so if you do option minus, where is it? Actually, it stopped showing. But yeah, if you do option minus, it actually will give you this assignment operator. But if you run this now, it happens the same thing. B gets stored in your global environment, nothing gets produced. But if you actually go to the console, so we have only talked about how to run things in the source panel where your script is saved. But you can also go to console and directly say, okay, A, and you say enter, it will print out what is stored in A. If you type B and enter, it will give you what is in B. And you can basically say, if you want to know what is you can do B, and this operator is just saying square, to the power, and you can say 2, so it basically is B squared. If I type this, it will do the math for me and give me these things. So far, so good. Because I'm gonna probably jump ship. I'm gonna jump ship very quick and go to things that are slightly different. But okay, so there are different kinds of data types. We'll move slowly towards CSV files and we're gonna load them in, but there are a few basic things. So for example, how do you know what type it is? So here, for example, the B says int, and it tells you it is it has 10 numbers in it. So both A and B are vectors. Vectors are basically a single, so you can basically think it's like a vector is basically a single string of elements. And the elements could be characters, it could be new numbers, it could be vectors. So if I type here, for example, blah, 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 how do you know how many elements are in your vector? So you can say length of A. When I say length of A, even though it says blah, 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 3 things, it's all within a single quotation, right? So it is basically of length 1. Whenever you want to have multiple elements in a vector, you use the thing, you basically start with C, which kind of like, I don't know what it stands for, but it's more like how I remember it is like it concatenates or like it cats. It is basically appending different things to a vector. So I can basically say A, B, C, right? I can basically write these three things and I run it, and you hear down here, now you see it's basically says the CHR, which is a character vector of 3 length. So if I run length of A, you will see it says 3. So this makes sense. So what's a different kind of data type? Can someone tell me? So there's vectors, but now if you go, that vector is always one dimension, right? It has a string of different things. It has basically a number of different elements in this one vector. What is a two-dimensional thing? The next thing, matrix. So a simple matrix would be, suppose I have this, B has what? B has, so if I type B, it has the numbers 1 to 10. So there's a function called matrix, which is going to convert certain numbers into a matrix. So you can basically type B, and then you go to, and you say, make this into a matrix, and it basically does. It throws everything in one column. So now you can start to think about columns and rows. And it basically says, oh, yeah, there's like here's our 10 numbers in a matrix format, right? But I can basically say, I want only 3 rows. And it says, oh, that's impossible. I cannot put stuff 10 numbers in 3 rows because, you'll have like 12 things in here. Just because, if you have 3 rows, it can't really fit. The maximum you can get is a 3 by 3 matrix, which is 9 numbers, so you can't have that. So if I say 5 rows, now it makes sense because it throws the 10 numbers in 2 columns and whatever. Okay, so this is great. How do you index? So how do I, for example, this is a matrix I have, and how do you know this is a matrix? So there's a function called class. Actually, I'm probably moving ahead, but let's talk about pipes. I think this is like a good thing. So you have seen this where I'm basically writing matrix parentheses, right? So everything that starts with everything that looks like this, some name, and then I have parentheses, that is the holy grail symptom that this is a function. This is basically what tells you whenever you have the parentheses is this is not just a random object, this is a function. So how do you write a function? So I'll show you because like it will be very useful as you get very complicated code to do something. So every time you want to write a function, you have to name the function. So let's say create matrix, right? I can say create matrix. So I name this, and then I do the assignment. And basically, I'm gonna create a function. So it always starts with the so function. This itself is a function. It can be slightly weird, but yeah. But this,
Hello.
yeah.
I just interrupting you for our extra novice folks. I wondered if you wanted to explain why you used the underscore there in your create matrix instead of a space.
Oh yeah. So names do not have space. So if I let's say, good question. So if I have like create matrix, suppose something something, and honestly, it could be anything, right? So I could say print, and I say hello. Right? So let's run this. So what it's doing is it's creating this function here. Now you see in your global environment, it is a function, not a value, create matrix, and it does something. So if I type create matrix and I run it, it says hello. That's all it's doing. But good question, Laura. So if I do not do the underscore and do, it will say a random error, an unexpected symbol in create matrix because spaces are not allowed. Whatever you name your objects, your matrices, your tables, whatever you use, but dots are allowed. If you do this, it generates a new function called create.matrix. This is the formatting or styling we like is most times if you have a space, if you want to separate 2 words, we prefer underscore, easier to like also split and do things later on. So yeah. Now suppose the useful thing about functions is it lets you repeat something over and over again, so you don't have to like recreate. So suppose I say create matrix, and I want to basically give it some vector. So I want to give it, and I'll tell you what this is, but we want to give it some vector, and we want to actually create a matrix from this vector of numbers, right? So what we'll do is take this thing we did before, and we'll throw it in here. So basically, instead of B, we will say take whatever the user is going to give us. So every time we define a function and anything in here, so nrow, for example, equals 5 is a parameter. B is a parameter. So how do you know what parameters are? So you can, if you want to know more about this matrix function, what you can do with it, the useful thing is you can always go to console and say question mark the name of the function, and what will show up is a help page. And it tells you what kind of parameters it takes. And the parameter is just saying letting the user define certain things, and the function will do the rest for you. And that's how you create the ABCD scores package. Is like, you give it something, and we have already pre-coded everything you needed to know. Okay, I'm just like, be aware of time. Okay, this is good. Create matrix. So vector is something the user will pass, right? And then I can also say, how many rows do you want? I can say rows equal, basically, the user can also define the number of rows. So instead of nrow equal 5, I will say rows, right? The moment I run this, now again, it's a function. It's called create matrix. But when I say create matrix and I run it, nothing's going to happen because we haven't given it anything yet. So how can someone tell me what can I type in here for vector? So create matrix, I just created a function. I want to give it, a vector is a string of numbers, right? Someone give me a few numbers. How would I write it?
Wouldn't you just do number, comma, number, comma, number, comma?
So do you want me to say 1, 2, 3?
Yeah.
Okay. And then for rows, right, that's the other parameter. I want to say, okay, maybe I just want one row, right? Why is it not going to work? This is great because can someone tell me why it's not working?
You're missing the concatenation.
Yes. So a vector, the definition of a vector is like up here for numbers, we used 1:10, and that inherently converts it into something that is going to look like this. So every time you want to define a vector, you have to wrap it around a C. And if you do this, if I run just this part, so again, there's another thing you can do in RStudio, like you can highlight a specific thing within a bigger thing, and then you can run command enter, and it will run it. So now we have a vector. That's all we needed to do. And if we run this, it gives us basically what we wanted. It takes these 3 numbers and makes them into a matrix, right? So if I want to now like say, give me 3 rows and I run it, it will now give me 3 rows, which becomes 1 column. So in this way, you can define a function to do anything. All we did here was we know we are going to use this matrix function several times, and each time the B will change, how many rows we want will change. So we just defined it for ourselves, and then we can just like pass it on. I mean, this is like a simple case. You don't have to make it for this, but we'll get there. Okay. So I'm going to jump ship a little bit, and actually, no, the last thing I want to do before I go to like pipes and the different kinds of other so we have talked about vectors, we have talked about matrices, and naturally the next thing comes is a data frame, right? But who has used pipes? So pipes are basically, suppose I created this matrix, right? So the value of this matrix is not currently saved anywhere, right? If you look at the global environment, we have only like A and B. We haven't really saved it. If you want to save it, we can call it C or mat. We just call it mat. We save it, and you'll see now instead of values, it is a data, because it's like going into the realm of data. Matrix is like a 2D object, so it's a data. But suppose we want to know what is the so suppose you have someone's code and you want to know what is mat. So you can say class of this object mat, and it will tell you what it is. It's a matrix or an array. In the same way, class of A tells you it's a character vector. But pipes are gonna be our lifesaver, because sometimes we don't know. Maybe we're gonna do a lot of things with data, and we don't know already ahead of time what we're gonna do with it. So pipes is all it does is so I can take this thing called A, this object, and I'm gonna pipe it to a function. So the pipe is basically passing on something to a function, right? And here I'm gonna say class. And if I run this, it gives me the same answer. Instead of A, I can say, I can say mat and class, and it gives me the class of that object. And how it works is it basically passes on this thing. It's basically the same as writing class mat, right? Now we'll talk about slightly different things. So let's say I create A is going to be 1 to 100. And I create B, which is also, let's say it's 101 to 200. So I create A and B, and a plot is a function which will plot, it's a generic thing that comes in base R, and I can plot A, which generates basically, gives me a straight line because it is plotting A on the y-axis and index like which element it is. If I plot B, it will go from 100 to 200 because the 100 elements we have. And you can plot A comma B, which is going to basically do that. It's plotting A on the x-axis and B on the y-axis, right? So how would you do this? Suppose I want to plot, so I can say A, and I can say plot, and this will work. In the same way, there's something called hist, another plotting function, which just gives me a histogram. So you take a bunch of numbers and you create a histogram. And you can do the same thing for a box plot, and it will give you a box plot. So already what we have to, all we can think about is we just need to make sure whatever comes before this command, we have already figured out, and we can play and change. And the good thing is you don't have to delete this. So another command that we use a lot is Command-Shift-C, which just comments out a whole line. And in the next line, I will say, okay, give me the hist. And I don't like the hist. So you comment this out and you go back to your box plot. You will basically use the same command, Command-Shift-C, to uncomment, and you will run it. So pipes just let you stitch together a bunch of code, and you don't even have to delete things. You can just comment it out and piece together different things. Any questions about pipes before I move into the table and data frame? I mean, the questions probably will come in a second. Okay, so I'm going to move into data tables. So let's take a pause for all the code, right? Where am I? Okay. The data I want to explore today, just because very topical. I was exploring. I asked people what they want to explore, and the majority says surprise me. So here's the surprise. I found this website where they are documenting the number of NIH grants that have been disrupted, frozen. They've been tracking what has been happening with NIH grants over the last couple of years. Actually, yeah, last year or so. And they have a lot of different data columns. And since we have a lot of Airtable, I think this is an Airtable that they are displaying on a site. And I will give you the link, and also I'll give you all these like resources after the workshop. I will create a little website where you can see all the different things slightly more organized. But yeah, so they have different columns, right? They have like the award number, different kinds of award number. What is curious and what I thought would be very interesting to look at is like, what is the current status of these awards? Were they restored, or were they disrupted and still disrupted? And then they have some detailed status about, okay, were they frozen, unfrozen, reinstated, and stuff like that. They have title. They have some dates of when things were disrupted. They have some, yeah, again, dates for like when it was frozen, unfrozen, blah, 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 blah. But what they have also is which university it was. So I'm trying to find that. There's like, of course, thousands. Like this is like a good use scenario. Maybe you just like stumbled upon a data set you want to explore and like see for yourself, right? So they have like some words that were probably flagged that was in their abstract. They have spending category. So you like Airtable, you can look, okay, they have substance misuse, alcoholism, alcohol use. And then they have the organization name, which university it was, which city it was, and what kind of like grant it probably was. Like it is a R01 and blah, 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 blah. Okay. So I just wanted to explore because I've never looked at this data set before. I'm like, this sounds interesting. So what you can do, the first thing I'm going to give you is, if you have the link, you should be able to just download this CSV file onto your computer. If you don't, I can also just like throw this in here because I have it. Where is it? So terminal. Okay, data. I'm going to actually give you 3 different things and I will talk about it later, but I hope it lets me attach. Doesn't? No, I don't think it lets me attach. So I'm going to just email these to you. But in the meantime, you can take a look at what those things are. And let me find my thingy. Reply to all data sets. Okay. So just send them out. It'll take a second. But while you're doing it, I will just load the data to just explore like what we have in the data set, right? Just to like this demonstrate a couple things. Like how do you, so let's say I'm gonna now, and I'll remove this environment, but you get the general idea of like, if we assign something to an object, a name, it gets saved. If I don't, then it will basically not be saved. And we'll go through it ever so slightly. We'll probably take a break in like, it's 1:42. So how are guys feeling? Like, do you want to like download those files and come back in like 10 minutes, or do you want to keep going?
I'm down to keep going. Still waiting for the email to come through though.
Okay.
So
Oh, yeah. Yeah, if you have the link, you can just directly download this this CSV from the website. Should be faster. So I have the data. So in this folder called data, right? In your case, you might download it, and it might be in your downloads. So how do you even get the path to which from which you have to read? So suppose you're in downloads. The other way is to write full path. So I have right now. Sorry, go ahead. Anyone? Okay, so if you're in Mac, if you do this tilde, I think it works in Windows too, I'm not sure. But if you do // you're basically now going into the realm of you can see your downloads folder and other thing. So currently mine is in GitHub, actually, documents. It's in documents, it's in GitHub. And if you type the tab, it usually like tells you what else is there. Then it's workshops, and then it's DPLYR TIDYR, it's in data folder, and finally I have saved it as NIH v3 terminations.csv. So let's remove all of this. So read.csv is basically a function that will read a CSV file that you have stored in your thing and will read it as is, right? So if I type this, it's a large file. So something like this should show up. It's like it's just trying to fit everything into your console and cannot, just because there's so many. You saw we have like, I don't know, 20 different columns in there. So it takes some, it's like not pretty. So DPLYR, so let's load DPLYR. Now comes the, so to load a package, if you don't have it, then you'll have to do install.packages. And then here you write DPLYR, but I have it. The other way would be to go to your, so this little tab, which had like files, there's a packages tab at the top. There's also the plots we've been staring at. So in the packages, you can click install and do it. You can search if you have it. So I have it. I know I have DPLYR. If you don't, you just like do this install.packages, DPLYR. And once you have it, you can use this library as a function that will load a package and make the functions. So a package is a collection of functions. That's it. So if I do library DPLYR, so read.csv is not, it's like a base R function. You don't need DPLYR for it. When you do read.csv, of course, it gives you this ugly little thing that you can't really look at, but we can pipe this whole data set into a function that will make it slightly prettier. So you can, so this is called stibble. Now tibble is, so right now if I say class of read.csv, we have done this, right? So what is the class of this giant thing? It's a data frame. It has columns, it has rows. It's not a matrix, it's slightly fancier matrix with different attributes, like different things we can do to it. So it's a data frame. But if I say as.tibble, and then I check the class, it's gonna say, oh, it's a TBL, which is like a tibble, or a TBLDF, and a data frame. So it basically, it's still a data frame, but it has some extra things you can do. And what are the extra things? If I remove this class and I run it, command enter, now you actually can see things in your console. And what you're basically seeing, it makes it prettier. It displays it prettier. Just because it has this much space, it only shows the first 3 columns, and it says, oh, you have that many. It only shows the first 10 rows, and it says you have like 5,400 more rows, right? And 51 more variables. Variables are your columns. So it has that, basically it has that many. So how do you even know how many columns and rows you have? You can do this thing called dim, which is dimensions. And see, we are piping now. We have started our process of piping things through. We're basically saying we read this CSV file, we converted into a tibble. Now I just want to know the dimensions. And it says, oh yeah, this many rows. Always, whenever dimension is displayed, it's rows and columns. So for example, I want this number, right? Suppose this core award number. For some reason, I want to extract just this element from the table. So how would I do that? Index. So this is where we go into index. So we had our matrix, right? Let's look at our matrix. So this is the matrix where you have 3 rows and 1 column. And to extract this number 2, I basically will have to, every time we do a square bracket tells you that we are now going into the element and we're going to extract things. And it's always going to be row and column. Not basically these things, but it's like you're gonna you'll separate the row and columns. You're basically, if I want 2, it is going to be the second row, comma, and of course it has only one column, so it's going to be 2, 1. And if I do this, I get this number 2 back, and it is not a matrix anymore. We have extracted the value. So if you look at the class, it's going to be a number now, even though we got it from a matrix. So this is like basic indexing. And you can do the same thing with read.csv, right? Like when you have let's say we want to save this now, since we have loaded it into this thing called dat. So if I save this, if we look at our environment now, dat exists. So I don't have to do this read.csv every time I want to do something with the data set. So if I look at that, I said it displays nicely, and I want this number that's, the third core award numbers, RO1, AA, blah, 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 blah. You can use the same principles of matrix, and you're basically saying, hey, I want the third row and the third column, basically, right? So if I say the third row, comma, third column, it gives me this exact same thing, RO1. But unlike matrix, this still retains it as a data frame. So you are not extracting just the unit, you are getting basically a data frame with 1 row, 1 column. Okay, so, but you don't have to do any of this. We're going to do just DPLYR stuff now. DPLYR has a beautiful thing which is called a glimpse. So I can take this data frame and I can basically say, take a look at it. Glimpse is just a function that now you can see everything in the data set, and you can see the first few elements. So all the columns are now shown as like rows here, just so you can see what's in your data set. And you can already start seeing what values might be in each of these things, grant ID, subgrant ID, blah, 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 blah. So you gotta get a sense of what these are, what these columns are. The other thing to know is like data frame is slightly different than matrix because each column can have a slightly different type of data. So you can see the first column is a character, then subproject ID is integer, it says int. Then you keep going, you have some that is logical, which is true, false. LGL, that's what it means. And a bunch of stuff. But we know there are dates, right? There are a bunch of dates. First termination date, latest termination date. And we'll do stuff like we will change the format of this and we'll go through it. So before I go, I wanted to introduce you to a few. Go away. Does everyone have the data set? Did you get the email or still didn't get it? Got it? Okay. Everyone can do the read.csv. You can load it into RStudio. Okay. If you do get the email, also download the other 2 files because we're going to eventually merge them, and we'll talk about that later. Okay, so we went through pipes, right? So DPLYR. DPLYR is a collection of functions that very easy to remember. So filter is one. There's 3 primary things that we're going to talk about. Then there's different flares of it. But filter is always going to reduce the number of rows. So when you think about a data set and you want to suppose you have a lot of people and you want to only get a few rows that have some value or have some logic you apply. So filter is always going to be to reduce. That's all this saying is hey, I want to get this specific row. It will just filter and give you fewer rows. Distinct is a different flair of filter. It just removes redundancy, and we will talk about it in a second. Then you have where's select? Yeah, so you have select, which is going to be kind of the same thing for rows, but for columns, where we're selecting a specific columns either by name or by a logic. And then pull is going to just grab the elements of a specific column. And so let's say I want to get all the grant IDs, right? So currently this is a data frame. We know that this is a data frame, but we want to get a vector of all the grant IDs. Sometimes you want subject IDs, right? You have done some processing and you want to get like, what are these IDs that actually are problematic, so you can go do something else. So pull will give you that. So if I say pull, and if you save a data frame already, since it's saved, I can basically say pull and I think it's called, what is it called? Grant ID. So the moment I say GRA, so it already shows you what's available, and you can just do tab. And if you run it, now you get a vector of all these different grant IDs. And if you look at the class, it's going to be a character vector. So it's now a character vector, right? But we want to select. And I already have a few different things we can select. So I can say select grant ID, and now you get a data frame with just that column. So that's the difference between select and pull. And okay, so there's a shortcut in which you can copy a line into the next line. I mean, again, if you're interested, that's fine. Command option below, like the down arrow, or command option up arrow. So here I can like comment it out and I say, okay, pull. Suppose for some reason you wanted to do that, you can basically see the difference between the two different things. But I have a bunch of different, so select usually you'll use to only take the columns you're interested in. And right now I'm not interested in all these things. All I want to know is, suppose I have like a list, but it's basically grant ID, right? You have, maybe we have current status, detail status, and we're not going to do that much with start and end, but we'll just say frozen date. We're interested in.
How did you get it to populate all of the columns?
Oh, I had it, I sneakily had it separately saved somewhere.
Gotcha.
You can type it out. So there's another thing, you can type out all these things, right? Yeah, I mean, that's what I did first time, is like I went through all the different things. So the good thing about, suppose you want to select the different columns and you already forgot what these are called. So you can always type glimpse. So I'm going to remove this, right? So we were already in the process of selecting, but if I type glimpse and I don't pipe that yet, right, you get to see everything all again. So you can quickly take a look. I'm like, okay, I want this, I want that. You can write down the things you want. Flagged words, I'm not going to look at, maybe. And again, if you don't care about award value, but for some reason you had it in there and you don't want to delete it, but still keep a track record of it, you can, again, comment it out and it will not get selected. Glimpse is nice. Sometimes I use it because whenever you pipe the output of glimpse, it still retains the data frame. So you can basically have glimpse somewhere in the middle of your pipe to quickly take a look what happened before I did something. And then you can again glimpse it after you did something, just to see what was the difference. So if I run this, you get this thing on the left side where it says, this is the second glimpse, and it says, okay, I have only 9 columns and that many rows, 5,478. And this is from the glimpse, the first one right here before I selected, and it says I have 54 columns, the same exact number of rows. So select does not reduce your rows. It just is selecting for the specific columns. So this is one way you can subset your data. And this is probably the first process where you're going to start subsetting the data. And I can call it sub, because I don't want to, like, sometimes it is easier to just save it so that, you can make your code slightly modular, like, okay, I want to just save this here and we're going to work on it again. So if your console becomes crazy, you can always clear it and you can do Control L for it and it'll clear, go to the top. Okay. So one thing I wanted to talk about is there's now, if we can just even look at, so view is a function and you can view a data set and it opens this nice little thing in RStudio that you can use like you're used to, like a Excel or spreadsheet. You can basically take a look at the data, right? And again, I wrote it this way, but I want to use pipe. Can someone tell me how I can, instead of writing like this, how would I use pipe in this scenario to rewrite this code? So I start with the data set that I want to pipe into a function, and the function that I want to pipe into is called view. So if I type this, it's exactly the same thing. And this is going to be useful suddenly at some point you're trying to debug and like what just happened there. I can just quickly view what, and so I can comment this out and go to a new line. And the first thing I want to do is, hey, let's take a look at what we had, right? And we have, let's see. So the more wide you make your console, the more number of things you can see. So that's the that's what you're working with. All right, so first thing I want to do is I want to know, I want to count. I want to know there's like a lot of different universities in here, and each university could have multiple grants. I just want to know which are the universities that were highly affected by all this pausing and unpausing. Anyone who exists in this data set, their grants were at some point paused. So we know these have been affected at some point. So what we want to do, suppose you want to only now focus on the columns that you're interested in so we can actually follow how the transformations work. Not necessary all the time. So we want to do is we want to select, what would we select? We want to select the name of the institute, right? So which one is that? That's the org name. So we can say org name. And suppose I also want to know what is going on with the org city, just because maybe at some point I want to count over the city instead of the university, right? And I want to know what's up with the current status. So what is the current status of that? So if I just select this tree and I run it, you can see it right here. You basically will get that. But I want to count. I want to know, for example, Brown University, let's take a look at this. And so you have each row is it's a separate grant, right? So I have this first three is all about Brown University, which is in Providence, and the current status is restored, right? But one thing you can do here is like in the view in the table, you can sort it, right? You can basically arrange it so that the universities kind of stack up a little bit. But we don't have to do it manually. What we can do is we can use this function called arrange. Actually, let me give you some vertical height so we can see stuff. So there's this function called arrange. And arrange is going to just like do the sorting for you. And I want to say I want to arrange it by org name. And if I do it now, you'll basically start to see it does it alphabetically. So academic, pediatric, blah, 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 blah comes first, and access health, the 2 rows of access health shows up here. Then Alabama State University is here, and da, 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 right? Suppose you want to do it the other way, where you want to have in a descending order. All you will do is, again, every time you see me like so desc is a function. It will just say it's the descending order. Descending order of what? Descending order of the org name, right? And otherwise, we can also do org name and pipe it into desc. However, if you're really into pipes, you can do that. Sometimes if it's like simple enough, I'll say, okay, descending order of org name. And if I run it, now Yale comes at the top. Okay, this is one way you arrange if you're just looking for things. The other thing I want to do is count. Now I want to know how many combinations, what are the unique combinations of org name and current status. So all I want to do is count. Oops. So count is a function. And you can basically say, give me the unique combinations. That's all it's saying. How many unique combinations, how many rows are there for each org name? and then it's basically going to be current status. And now you have a slightly different column here. The third column is n, which is number of rows, which in our case, and count, this n is by default, but you can name it. So if you type name equals, now you can name it. And it is number of grants, right? So that we know what this n is. If we say n grants, then your this count column becomes n grants. And you can see basically, okay, Academic Pediatric Association, there's one that was restored. Suppose I want to only look for, suppose I want to only look at the rows that are Yale University. So which DPLYR function will I use to subset the rows to only the org name that has Yale in it? So we have filter, yes. So again, so see, we're chaining things. We're already doing stuff, right? We have subsetted it, we have arranged it, we have counted it. And now on the count, I'm gonna now filter. And you see here, we have like 622. We started with 5,400-ish rows. The count reduced it because it is giving you a count of how many rows you had. And if we filter, it's gonna go even further down. And filter the org name. So I don't even know what the Yale University's full name is. How do I find that out? Like, how do I know what is the org name for Yale University here? So you can do a view. If you're in RStudio, this is easy. You come here, you have a search button at the top, and you say Yale. And you see there's like 3 different things that are called Yale University. Well, actually 2 different names, right? So maybe I just want to look at the whole Yale University. So you'll just copy this. You go here and you're like, okay, now, well, maybe let's leave our view, comment it out. So every time you comment out, that line is not run. And you say filter, and you say org name. Now, logical. So we looked at equal sign. Equal basically is a logical thing, which is saying, is it true or false? So I'm saying org name equal, and in parentheses, because it's a character, I cannot just type Yale University. R doesn't recognize that as anything. So you have to always put that in quotation. So if I do that and I run it, now I get just Yale University from that count table. And I can quickly see, okay, there are 25 that are still disrupted, 17 that are restored, right? However, we looked at it, and there's this issue, right, where some like this is one which is called Yale Univ. So how do I get that in there? Of course, I can basically say I want to look for that university, or so this sign here, the God, I don't know what this is called, but this flat vertical line that you'll find probably above your enter or return is an or indicator, and we have it here. Where is it? So there are different things you can use with filter, greater than, equal to, blah blah blah, but also this or and and. So what we're going to say is like, okay, org name is either Yale University, or org name is equal Yale Univ, right? And if I type that, now you basically get that other one, that one row that we were missing previously, you get it. However, there might be like hundreds of these cases, and you don't want to go back and look at the data table all the time. But you know all of these start with the word Yale. So filter actually lets you do that. And this is like, cool. So I'm going to do is like comment this out, and we're going to rewrite this, say filter. Now there's this package called stringr. If you don't have it, you'll have to install it. So again, if you don't have it, don't worry about it. But if you do, you can type. So far we have just used the function name. We haven't said take it from DPLYR, right? But because I only loaded library DPLYR, I have access to all the functions in DPLYR. And I intentionally am not loading any other packages, so you can see which functions come from a slightly different package that is not dplyr. So stringr is a great package which lets you do a lot of stuff of like matching strings and subsetting strings. And it has this function. So ::, so you write always the package name, then : just gives you access to the different functions. And you'll say str detect. It's actually very easy to remember if you remember like all the stringr function starts with str_. And then what do we want to do? We want to detect in the org name column, comma, which string it should have Yale in it. So if I type that, it gives me exactly the same answer. Anything that has Yale in it, row, will show up. If I say anything that it starts with Y, then it gives, or anything that has Y in it, it gives me everything because every university probably have Y in it. And this is where, does anyone know how you say, give me like the same syntax, but give me the rows which starts with Y? So there's two syntax that I want to, so this is all regular expression and gets very complicated, but for most use cases, you just need to know what is the syntax to say that it starts with Y. It is this, the power or whatever you call it, this, I don't know. Can someone tell me what this is called? But it's
I call it a caret.
Caret. Yes. The caret before the letter tells you that this is what it starts with. So if I now run this, we get back to this. We have only, with Y, we have only Yale, right? If I want to see if there is any university that starts with S, for example, there's plenty, right? Maybe you want only the one that starts with San, maybe San Diego, San Francisco. You can do that. And it only gives you the one that starts with San. And the other way, how do you say, so this is like, it starts with, I'm just going to leave it here. And this is another thing of like commenting out. You can just comment it out and you go back, go to the next line. You're like, okay, let's write another example. And I want only the universities that ends with TY. And the way to say that is like TY, and then you say a $sign to basically say, okay, it ends with TY. So this is basically starts with, and and this is ends with. So you'll get only the things that have university in there. Questions? Okay. We did filter, we did select, right? Select also has this other thing. So remember when we selected by org name, org city, current status? Suppose we know that there's only like 2 column names that start with org, right? So instead of like writing this out, so let's, I can like, as I said, like it's nice to like have this piped because I can always go back to a certain step and look at the status at that step. So if I glimpse here, I'm just going to remove this glimpse up here. So I see, so far I have like this 3 things selected out by select org name, org city, current status. But instead of typing this out manually, I can also say there's this function called matches. And here you can use the same regular expression that we use for filter. And we want to say that give me only select the columns that matches a certain string. And I know these are all starting with org. So I'll say caret org. And what it will do is exactly the same thing. It will give me the 2 columns that have org in it. If I want, and I know there's a lot of dates here, I could basically say, when you say comma, it's basically saying, okay, give me this and that. So I can say matches, and I can say it ends with date. So I can say date, $sign, basically all the columns that ends with the date, and you will get the dates. So this is a quick and easy way. You don't have to type everything out if we know, and that's why curation is so important. And that's why, Laura, Kaylin, and Sammy probably spend so much time curating the whole release names is so that programmers can go back and do these things later on. It's like by just like using regular expressions. Okay, so we have filtered, but I actually wanted to let's go back to our, again, so commenting out, I hope this doesn't confuse you, but I'm commenting out chunks of code so I could have access to it later and I can share with you all. Org name not found, glimpse view. So right now, this is what we have. We have all the different org names we had. We have the statuses, and we have the number of grants. But this is not a great way to look at it because I want to look at it in a slightly wider format. This is like a long format, right? You have for, let's say, Boston College, you have disrupted and restored, but I know I can basically look at it side by side, how many are restored, how many are not. So this is where I think we're moving into now some of the TIDYR functions of how do you take a data set and you move it slightly this way or that way. So one thing we can do is now here, again, we can do a glimpse to quickly look at what we have. We have org name, we have current status, and we have number of grants. And what we will do, can someone tell me how, so right now we have number of grants here, and it's if you look at the view, it's capital V, so it will give you an error if you are not getting it. But the grants are all it's all organized by org name, but now I want to organize it so the number of grants is, the maximum is at the top. How do I do that? So which function is used for sorting a column, sorting by a column? Hint, hint. Arrange. Sort is also a function used on vectors in DPLYR's arrange, and I want to arrange in the descending order for number of grants. And what this gives me, it brings the most highly affected university at the top, right? And suppose I only want to look at the top 20 most highly affected universities. So what I would do here is actually say, show me the head of the most 20. So head basically gives you the topmost rows. So if I say head 20, it gives me the first 20 columns. Oh, sorry, 20 rows. And you can quickly take a look at it. But this is not a good way to look at it because for Columbia University, there might be, so these are only showing the restored, but there might be disrupted that we're not seeing here, right? So before we do any of that stuff, we're going to pivot. So TIDYR, again, I didn't load TIDYR, so I have to use TIDYR : to access its functions. So pivot is the generic word. If you want to pivot, so this is called a long formatted because, for each university, there is multiple rows. There's one for restored, one for probably disrupted. But I can say pivot wider because I'm pivoting it wider. And how do I know what's in this? So again, you will always have questions about how do I know what goes in this function, how to use this function. You can do question mark, that function name, and it gives you a bunch of things. But most important would be if you go to the very bottom, it gives you some examples that you can try out. So the most important one is actually names. So I'll try to work through it. So what it's doing is it's creating extra columns because we're making it wide. So one of the things you can think about is where are these names of the columns coming from? And it's coming from this column called current status, right? Because we want them to become columns instead of being in rows now. Oops, current status. So the names are coming from current status, and where are the values coming from? it's coming from ngrams column. So if I type ngrams, and now I look at it, the data set that look like this, where you have like a column that tells you if it was restored or disrupted, and ngrams just tells you the number of grants that are that status, now becomes this easier to look at it, because I can know for Colombia there's 893 that are restored, where 30 are still disrupted. Okay. The good thing is it's already like arranged by number of grants, but what we can do, if you want, suppose I want to now look at, I can arrange in descending order of disrupted, because disrupted is now a new column, and I can just say arrange it so I can see the most disrupted university at the top, and you can see, okay, the most disrupted, so it's currently is Duke University. So you're like getting some idea of what's going on, and yeah, I mean, so the one thing, and the plot function. So this is like where I really wanted, like, and I'm gonna just show you this, and then I'm not even gonna talk about it. But suppose you have this data set, right, where you have the names in one column, you have a few different columns with some numbers, and you want to just like look at it instead of like instead of just reading these numbers. So I can basically say, take the head now, the first 20, because I don't want to look at everything. I just want to look at the first 20. And I have a piece of code, and I'll briefly talk about it. Maybe I will actually have it in the document I'm going to share later. But there's a package called, so I'll load this package called plot.matrix, which uses the base hour plot function. So if I run this right now, the first head of the first 20 rows, and I say, okay, org name. I'm gonna just like, oops, x-axis, da 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 da. I don't need that. Okay. Whoa. Let me get. So when you're using base plot, you can also set the margins. And if I set the margin, you actually start to actually see stuff now. So it's the same thing I'm gonna like show side by side. If I go here and if I look at this view, so side by side, if I look at both the things, you see it's exactly the same thing, but instead of the table, you now have like a quick way to like visualize what you're looking at. And one thing we can just see is like, okay, Columbia University seems like they have like a lot, even though a lot is like disrupted, but majority of them, a huge chunk of them have already been restored. If we want to also look at, suppose we didn't want to look by disrupted and we only actually wanted to look by, so I'm going to comment out a range here, and we're going to look at, the universities where most of the things have been restored. We are back here where you can see like Columbia, Northwestern, blah, blah, blah. And I can plot this. So this plot is slightly different than the previous plot just because these are arranged differently. I will share like what this code is and the function for this later on if you want to use it. But okay. So suppose we have this. I know we are running very close to the endpoint. So I just wanted to like show you the other use case where we have this format, right? We have like a data set where you have restored, disrupted, but we want to make them into now like a long format. So all you will do from here is, I'm going to just like display it on the side so I can have a good view, is just going to move all of this out of the way. So we're going to call TIDYR pivot. Now instead of wider, we're going to call longer because we're making a wide format into a long format, and false. So this is basically saying which columns do you want to take and make them into rows now. And the columns we have are, we basically can say C and say restored, disrupted, and then we have to still name it, names too. So basically, what are these names? Like we have to basically save it to a column, right? So where do they go? We're going to call it status. And oops. And the values too, we're going to call again n grants. And basically it went back to the same format where you have taken the wide format and you convert it into a. Okay. This is a good point. We had no breaks. We were already at 90 minutes almost. I am okay with staying on a little bit longer. I was going to offer it anyone who has questions or you have like things you've probably been stuck on way before. I'm here. No one has to. If you have questions or you have like things you want to like go over one-to-one, I can also show that. I wish I could show left joins and maybe I can actually. Do you guys want to see a quick example of join, or how do you feel? Overwhelmed? A lot of stuff?
I can stick on for joins.
Okay. Does anyone have questions before we do joins? I know like some of you probably have to hop off. So if this was your first time, Tilly, I'm sorry. I have dumped a lot of information.
That's a really great overview. I really appreciate you providing some of the files so that when I go through this again and pause and, I'll have all the information I need.
Yeah, and again, anyone, if you're going and like trying to use it on your own time or go through it and you're like stuck somewhere, feel free to reach out. I'm happy to like hop on a one-off call and like go over some of this. Okay, I want to like quickly show. For example, right now, let's say we did all of this with org name, right? How do we quickly change it to, we said there's org city, right? We did all the summaries based on org name, but we can do it by org city. So remember we counted, the main function was count. So instead of org name, I can say org city. And what would it look like if I do a view or a glimpse? It basically looks like exactly like this. Instead of like university names, now you get the city name. And we can use the same pipeline to actually pivot it wider, pivot it this way, that way, and we'll get back to this where we're looking at the cities that have been most affected. And it is New York where Colombia had a ton, so you kind of take a look. What I wanted to do, that's why I had like a couple other tables in there, is I just want to know, like, for these cities, are these cities Republican or Democrats? Right? That was my question earlier today, and I haven't even looked at it. So I just wanted to like, if you have some time, hold on, and maybe we'll find an answer. So we have done all of this mumbo jumbo stuff. What I can do is save it now. We have not saved it so far. We have just been piping one by one, and we'll just call it city counts, right? When I do city counts, let's say city counts, I get this whole list that we looked at, or the table where we have that many rows. Maybe I will only use the first couple, the top, however many. But what we need to do, we have like saved it and everything, right? We need to load a couple more. So I have this two files that I want to load. Where is the file? So one is this where it says for different states if the governor political affiliation is Republican or Democrat. And then there's the other one where it just tells me which city is in which state. Because I need to go from city to state and from state to Democrat or Republican. So how do I do that? So in files, you will see like the ones I sent you. There are the one we have been using is this NIH terminations, but we have these two other files that we can import. Okay, so let's say use US cities. I'm gonna read this read.csv, and I'm gonna use, the way you can use it is like if you knew the path of the other one, you can copy this over. And but this is gonna load this CSV file, so I'll delete this, and I'm like, what else is here? I want the US cities file, and already, when you're writing the read.csv, I want to take a quick look if everything worked out fine or not. It looks like it's fine. And honestly, all I need is, and here again, you don't have to do it in multiple steps. We'll pipes, we'll select. All I want is city, and I want the state name. Which in select, you can also rename at the same time, where you're saying, instead of state name, I just want to call it state name. So if I do that and I look at it, which is glimpse. So in one go, I have read the CSV, I have done this, blah, 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 blah. And I have this, I'll hold on to it. The other one is, let's say, city politics, or I don't know, whatever. City politics, right? And I can say read CSV. And again, I will copy this whole thing, but instead of the CSV file, I'm just gonna say, give me city political party. Let's make it slightly bigger so I can see. I need to close this quotation mark. And again, glimpse to quickly see what happened. Okay, so this one is a good use case because it has some headers. Where is it? Where is my table? Give me. Okay, can you see the finder? Or no?
Yeah.
Okay,
Yeah.
Thank you. Workshops, DPLYR data, city political. So what do you see? Like this is like what the CSV file looks like. You see at the top, they have some random stuff. They have like a header basically, which is saying title, state, blah, blah, blah. They have a time frame, which I don't need. And the actual thing actually starts in basically the third row. So read.csv lets you skip a few rows in the top so that you don't have to clean it up manually. You can just leave it. So it's called skip, exactly what it is. And you are skipping the first two rows. And if we now do it, you'll basically see, oh yeah, we got what we needed. It has this thing. So we can even take a look at city politics and quickly take a look at what it looks like. And you'll see the first row is kind of like not what we need. It's like a kind of a summary across all US. And maybe we'll just look at governor political affiliation for now, right? So we want this first column, which is location, and we want the governor political affiliation, but we don't want the first row. So how do we do it? We'll just call it city pol sub. And actually, let's just do it here. So I'm just going to filter out where, oops, location I think was called US. So I'm just going to do a glimpse again, but I want to see, okay, so United, blah, blah, blah. So I'm going to filter to remove where the location, and this is like, instead of equal, I'm going to say exclamation equal, which is not equal. And I'm going to write it up. United States. How to check if it's working? You can say equal and run this, and you'll say, okay, there is like one. So one thing I already realized this might not be a tidy. So I can go back as Tibble, just add it here, rerun this, and rerun this. Yeah, now it looks better. Yeah, so this is the row that we want to remove. So instead of equal, I'll say not equal. And now it looks way better. And the same thing we did here for US cities. I'm going to name it slightly, select the thing I need. So instead of location, I'm going to call it state equals location. And I'm just going to call it FIL, which is the governor political affiliation. Oops. Let's see what happens. Okay, so this is what it looks like. The good thing is you don't have to even save it anywhere. You can save it to basically the same thing. We've been just trying it out where we type it. And if we do that, and we do a glimpse at the end, I'm rushing, but sorry about that. Okay, so we have stuff we need. So we have US cities that look like this. Again, whoa, this needs to be a Tibble. As Tibble. So US cities look like this. City politics looks like this. And then we have our city counts that looks like this. Now, one thing to realize is org city, all the cities are capital, all capitalized. This here, for example, the states are not capitalized, which works because these are not, but the cities here are all small. So we'll have to like do the merging, but one thing we can already do is like make everything capital, so we can just like easily find stuff. So all you'll need to do is go back to your code that you are processing, and here you say mutate. And mutate does like it actually changes values, changes formats, and what we want to say here is US cities. We want to change the city names to upper, right? So we're gonna say city equals, and there's a function called to upper, which basically will change it to upper. And if we do that and run this back, you'll see, okay, now city has upper, great. We also, city politics, we just have state, actually, so it's state politics, I guess, but doesn't matter. Okay, joins. We start with our count, city counts. We start with this, and we are going to only for the, let's say I want to look at the first 20 rows. And all I want is this extra information appended to this table. So left join is basically saying only add information that is existing in the thing you're joining to. So I'm going to left join to the city counts one. And what am I going to left join? First thing I want is basically the state for each city, right? So US cities look like this, where city column here and org city here should match up. And all I want is the state, right? So I say left join US cities. And if you run this, it's going to give you an error because it doesn't know which column. The column names don't match. If the column names matched, it'll be fine. So here you're going to say there's this thing called join by, and that basically tells left join which column to join it by. And here you can say org city is equal city in the US cities file. And if you do this, now you get the states appended to the first thing. Whoa. Boston. How is Boston and Georgia, Massachusetts, and everything? What is this? Doesn't matter. What I'm gonna do is let's take a look at distinct. All right. So this is an issue, like there were multiple in US cities, if I view and look at Boston. So if I look at this data set and look at Boston, there seems like this data set is just crazy because apparently there is like Boston and all this different state have Boston. So that's not a good thing. However, let's just join for now and then we can figure it out. So we know for each of these states, we have this city politics where state has a affiliation, Republican or Democrat. So what we can do is, now left join this data set to the one we already have, which is, it has org city, restored, disrupted state. And we're going to left join this one, city politics. And this time we're going to join by, it has state here and it also has state here. So we basically don't even have to do equal equal. We're just going to say join by this column called state. And it says, oh, I forgot a pipe after the glimpse. So if we do that, now we get to the realm where we have all the data. And what I will do for now is if there are multiple hits for the same city has like multiple states, I'm going to remove them just because we don't know what's going on with those Bostons, right? And we know this function called count. So we can basically say count how many, blah, 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 actually. So don't worry about it yet. I have not even mentioned group by org city. Group by org city, and we mutate. We're basically going to count number of rows, which would be n, and we get this number here. We're basically just saying group by each org city and see how many rows we have, which is just, the same number. It gets appended to all of these things. And here we can ungroup and filter, where I am going to only keep the one where rows are equal 1. So I have only a distinct one. So here, for example, I will remove even the head. Instead of like taking the first 20, let's take the first 100, just because it seems like we have a very small number in the end. And if I do this, yeah, we get something. View. So this is the top 100 cities, and we have filtered out some of these. And if you just look at affiliation here, yeah, I mean, so how do you count? So now we have this, we can basically count affil. And it just tells me of the things we're looking at, we can't find affiliation for 14 of those, 15 have Democrats and 8 is Republican. I mean, this is not the best way to do it, so rushed. Usually you'd want to carefully think about it, how many things you want to like, how do you want to like find good data? Because right now we have like Boston that is a city in so many different states. It's just hard to do it. But at least hopefully this gets you an idea of how you can like take 3 different data sources, put them together to ask a ask a question about something that interests you. I'm sorry, the last part is fairly rushed, but I just tried to like hopefully accommodate as much of the DPLYR and TIDYR things here. And I will do my best to create a document that reiterates everything, probably in a little bit more written way. So you can play with it at your own pace later.
This is more for my own, so if anybody needs to hop off, they can feel free. But for filtering, is it possible, or rather, how could you filter based off of every value that exists within a specific column and filter those into its own data frame? So one common thing that I do is splitting all the data up by site. So what would be like the appropriate way to, you could use city or state or whatever in this example, but to create new data frames for every row that has a specific value.
Okay, let's go to then our original, let's call out, no. So let's go to this sub, right? Where you have, so you have a bunch of blah, 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 blah. And let's say we want to do it by city, right? You want to filter by city and you want to create each of them being its own data frame. There is something called group split. We haven't touched on list yet, but group split will org city. So what it does, it creates a list. So right now we have 269 different elements, which basically means you have, and each of them is a data frame. All it did is it took all the unique org cities there, and it split that into like its individual. But the return type is so if you look at class, it's going to be a list, a vector of data frames. And how do you save it? Is it's slightly different, but you can basically save it as like a df list, right? So you save, oops, gotta remove the pipe. So now if I have df list and so two brackets to get into the list, and then I look at the first element, it's going to be this, and you can basically look at it glimpse like a data frame you would do. And this is your Albany, for example. If I look at the second one, it has more rows, 7 rows, and it is Albuquerque. Now, how do you save this? So you can write a for loop, or you can do per. So for loops would be like for I in, let's say, 1 to 10. And then you have like curly brackets, and you say print I, right? So if you run this, it just goes through things and does something. So if you want, what you will do is like for I is 1 through length of df list. So you want to know how many data frames are in that list. So you can say length of df list, and it will tell you is 269. And here you can save it as, now if you want CSV, you'll say write CSV. And you'll say which one do you want to save. You want to save the ith element, which will, iterate through 1, 2, 3, all the way to the last one. And you can name it however you want. So it will be like, if I want to save something in the output file, where is it? Out? No. Maybe I'll save it in dev, and I'm gonna call it file. Now you can create, programmatically create, of course, paste 0. You can say, okay, this file underscore, and you can basically say, okay, this is the ith file, so I'm going to save it like this, and then say .csv. If I run this, it's going to save all of those. So I'm going to run it. And if I go to my dev folder now, here we go. We have all the CSV files that you need.
Yeah, just that's a possibility to do that, but I'm not sure if it's necessary to create several data frames. What you could do is to loop. It means to iteratively go through the different sites, and then to in your loop filter by site, and then export with write.csv. Maybe we could do that. It's less natural to split a data frame into several data frames. We often it's an unnecessary step, but yeah.
Yeah, absolutely. So yeah, this group split part you might not even have to do. But also, why do you want different data frames? Like, do you create different data frames to send it to sites?
Yeah, so it sounds like looping it would also solve that, since it's just outputting the CSVs?
Yeah, so you could just like get a list. You basically you will say, okay, which cities are there? So you can say D sub org city. So for example, this just gives you all the different cities, but you want the unique ones, right? So you would just, and this gives you all the unique cities, which is 269. And then here, instead of doing all of this df list thingy, you'll create your data frame by saying sub filter org city is equal cities I. So if I set I to, let's say, some random 4, cities is basically going to give you the cities number 4, fourth city on this cities list. And so this data frame will just be for Philadelphia, I guess. Yeah. So you have this, and you don't even need this all of this random stuff. You can just say, okay, save this.
Yeah, you just have to change on line 9 for I in cities, for example. Or yeah.
Yeah, you can do
And-
length, or you can do also cities. Yeah. So yeah, usually you can do it by indexing. That's why we number it. But as Olivier said, you can also do cities, which
yeah.
and that should also work. And the best way to look about all of this is like always try to like create your thing with this, and that gives you more like your loop works because it's just printing out what I is, and that way you can like know where to feed it.
Out of curiosity, in this use case for making the file names, is there a way to reference the
City.
yeah.
Exactly. So you would basically, so paste 0 is your friend, and you can create the file name right here. Let's say we want to create the file name, and you can do paste 0, or there's glue. You want to call it file, and then you want to call it I would be the cities here now, and whatever you want to call it. You want to date stamp, you can date stamp it, or you can just close it by saying CSV. And let's say you want, so before even saving, you can say print file name. So if you now loop through it, your file names are going to look like this, which is not good because you have a little bit of like, sometimes you have space, but
Yeah. Okay. But yeah, for Caleb's use case of doing things for each site, that should work because they're usually just like 3-letter indicators. Very cool. Thank you.
And you can do the whole to lower, to upper right here. So you can basically say to lower so that you have all lowercase stuff and not any uppercase. So you can do whatever you want to do with that city name.
Sweet. That's all my questions.
Man, I didn't realize TIDYR and DPLYR takes forever. And I couldn't even cover group by and all those things. But